Hello, this is a video to demonstrate how to calculate the values for various cash flow functions using both the factor notation and Excel functions. The book shows how to do both. The factor notation uses tables in the back of the book. The Excel function uses functions available from the f of x icon, uh, giving you an actual financial function that you can use to make the calculations. In this course, you'll be required to know how to calculate cash flow values both ways. Um, Sometimes you will be asked to use one particular method. Sometimes you'll be given a choice and you get to choose whichever of the two you want. So this requires you to have at least an understanding what some of the cash flows are that we're talking about. For example, single payment formulas are finding the present value of a future sum or the future value of a present sum. There are cash flow diagrams of these cash flows on the inside cover of your book, as well as the same thing for uniform series and gradients. So look in your book if you want to see what those look like, the cash flow diagrams. With factor notation, we calculate, for example, the present value of a future sum using factors that we multiply by the future sum that we're referring to. This particular method has a notation with three arguments in it. The first one, for example, P over F, refers to we are looking for the present value of a future sum, present amount factor. And then I% is the periodic interest rate. The period could be annual, or it could be monthly, 12 periods per year, or it could be quarterly, 4 periods per year. It could be something other than those as well. N is the number of compounding periods in a year. So if you're doing monthly compounding, N would be 12. So to find this factor, you go to the back of your book and you find the I% table. That's the periodic interest rate. Then you find the P over F column so that you're finding the present amount factor. And then scroll down the column N periods, and you will find then the factor that you multiply by the future sum to find the equivalent present value for the interest rate you're using. So I've described what to do, and it's easy enough for you to duplicate that from your textbook. Now for the Excel function, I'm going to also demonstrate it on the next Excel page in a moment. But with Excel functions, rather than having a factor for each different type of cash flow and a column on each page for each of those cash flows, we only have a few Excel functions, but they're more versatile. For example, our three workhorse Excel functions are the PV function, the FV function, and the PMT or payment function, but we can adjust them for whether or not we're dealing with various cash flows. So the equivalent present value version of the Excel function has 5 arguments, and we put in rate, which is the same as I, the interest rate, periodic interest rate. N per is the number of periods. The next field is the payment field, but we don't have any payments yet, so that's 0, then a comma. Then FV is the future value, so that's equivalent to the F cash flow in the factor notation. And then the last argument, we use a default value of 0, referring to end of period convention for cash flows. In this course, it's always 0 for us, so I'm not even going to get into much detail about it. The Excel function then will generate the factor that's equivalent to the factor notation and make the calculation. Now for the future value, we have almost the same uh, configuration, except for in the the fourth field, we put in a present value, not a future value. Now let's go down to um, uniform series and look at this first one. In this case, we're trying to find a present value that's equivalent to a uniform series of money, uniform payments for n periods. And it's pretty straightforward with the factor notation, but in the PV uh, Excel function, now we put that periodic payment amount, that uniform series amount, in the third field, the PMT field. We don't have a future value in this situation, so that's a 0, and now we get the equivalent amount that we would with this P over A factor. And my last example here before I go to the next screen is we want to find a payment, a present value, or rather we want to find a uniform series, what the payment would be for an initial equivalent to an initial value, say a car loan. And so in this case with the PMT factor, the third field is the present value. We don't have a future value, and it will calculate the factor to find our monthly or whatever payments. And there are no equivalent uh, Excel functions for gradients. However, I have created a clip that shows how to use Excel to find gradients, calculate gradients. That's another clip. So let me go to part 2, and we're actually going to look at an example. So for the car loan, we're going to use, for an example, we're going to borrow $10,000, and our nominal interest rate, the annual interest rate is 6%. This is not an annual percentage rate. It doesn't have compounding figured into it. This is the nominal interest rate, R. It's a 5-year loan. It's monthly compounding. So if we go down here to our next couple fields, the PV, the present value, is 10,000. The periodic interest rate, I, is the nominal interest rate divided by M, the number of periods in a year. So it's 6% divided by 12 months is a half a percent, but we're using rates, so it's 0.005. And N is the number of periods in our analysis, which is 5 years times 12 months, or 60. So for our functional notation, we want the A over P factor, I is equal to 1/2%, N is 60. We go to the half a percent table in the back of the book, go to the A over P column, scroll down to N equals 60, and we get a factor of 0.0193. Multiply that by 10,000, and we get our monthly car payment of $193.02. Now let's look at this using Excel. And with Excel, we find our payment function, which is what we're going to demonstrate here, by clicking on the f of x icon up in the bar above. Then it will give you an opportunity to look at different libraries of financial functions, or rather various types of functions. But under financial functions, you can find the PMT function. Let me see if I can demonstrate that. So if you pull up the function screen with the f of x icon, you can see that we have uh, under categories, lots of different types of functions. We want financial functions, and you can scroll down to the PMT function, the one we want. There it is. And then we can input um, the values in and find what the value of the factor is. Now, brute force method, we're going to go down to the payment function, type in 0.06 divided by 12 to get the periodic interest rate. Number of periods is 60. $10,000 loan. If I don't put anything in the other two fields, they default to 0, but you can see already calculated $193.32. Okay. Now method 2, we're starting out with the same thing. We have our payment function, but instead of, let me go ahead and clear that out. We're going to pull up our payment value again. But here, um, instead of typing in the values, we're going to click on cells where we've already preloaded the values. So for this first one, I'm clicking on 6%. It gave me B8. I'm dividing that by 12 in the formula bar, formula field. N per is 60. I click on that cell. PV is 10,000. I click on that. And now it has loaded all the numbers and I get my payment of 193.32. And then the last way is where it's very similar, but what I do is I simply just type in the cell locations, not the actual values, and then it'll make all those calculations. So the formula bar, in order to get the cell function to work, you need to type an equal sign before you hit the F of X key, and then it'll actually pull up the function. And so keep that in mind. In other words, if you're typing in a cell and you want to do it, you have to have that little equal sign. So anyway, this is how to use Excel functions and the functional notation to make cash flow calculations.